I am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. Welcome to the lecture series of image processing. In this session, we will see the topic Origin of Digital Image Processing. So today we are going to cover the subtopics like Origin of Digital Image Processing. So origin of digital image processing means we will be discussing from where the application of digital images were started and in which areas this particular concept is being used. So now coming to the applications of digital image processing. So generally nowadays digital image processing has a wide variety of applications like so in the origin of digital image processing we are going to discuss that. That means from where the digital image processing concept have been started and to where it is now. So initially the image processing concept has been started in the newspaper industry in order to capture pictures, and these pictures were sent through a submarine cable between London and New York. So this is where the first application of images have been started, that is in the newspaper industry. After that it have been started by using Bartline cable. So this Bartline cable is used for transmitting the picture, and this concept is being used in early 1920s, and by using this concept the transmission time have been reduced to 3 hours, whereas by using the previous concepts in order to make the picture transmission it used to take more than 1 week. But using this Bartline cable technique, the picture transmission can be made within 3 hours of time. The speed has been improved, and the picture transmission is done here across the Atlantic. And so here we can see one of the image. So this is the image that is being captured by using this Bartline cable. So we can see here, this is the digital image that is produced in the year 1921 by using coded tape and by using this telegraph printer with the spatial type faces. So when this picture is being captured, they have used here only 5 distinct gray levels. So that is why if we see the quality of this picture, it is somewhat less. And so this picture have been reproduced by telegraph printer with special type face, whereas this technique is being abandoned in 1921. That means here this technique they have stopped using from the year 1921, and the next technique have been came into existence in order to capture the pictures. So after stopping using this technique in the year 1921, the next method that is came into existence, that is the new technique that has been came into existence for picture transmission, is photographic reproduction, which is made from tapes. So by using this technique, you can see here, this is the image that is being captured. So this is the digital image captured in the year 1922 by using tape punched after signal have been crossed the Atlantic twice. Even though in this image they have found some errors. So if we see here, compared to this previous picture, compared to this picture and the previous picture, the quality of this picture is improved. Why? Because in the previous picture, using that technique, they have used only 5 distinct levels of gray. But whereas here in this technique, they have used here different levels of gray. Coming to the next technique, that is early Bartline systems. This is being used in order to capture the images. So in the previous images, what we have seen, they have captured by using 5 distinct gray levels. So the quality of that images have been poor. After that, the number of gray levels have been keep on increasing. And in the early Bartline system, the maximum amount of gray levels that are used to capture this picture, they have used 15 levels. So that's why compared to the previous picture, the quality of this picture is somewhat better. And it is being captured in the year 1929. So here, this digital image processing concept have also made to look at the other end, that is improvement in digital resources like computers. So development of digital computers are being done. So modern digital computers have came into existence around 1940s. Basically, while making the digital resources like computers, 2 key concepts are going to play a major role. So the 2 key concepts are, one is memory and another one is conditional branching, which will do a good foundation for CPU, that is central processing unit. So one thing is here main memory, because we used to have more sophisticated algorithms, large size of programs need to be executed and more amount of data need to be stored. So that is why we have to see that memory of the computer should be improved. So coming to the digital computers, what are the advancements, what are the improvements that are being made in the digital computers? So these are some of the points which shows the improvement in of digital computers. So here, main one is, in order to make computers powerful, we are going to use advancement in the technologies so that more amount of digital image processing tasks can be performed. So one thing here, initially, so transistors have been invented by using Bell Laboratories in the year 1948, and after that they have invented high-level programming languages like Fortran and COBOL, and next they have invented ICs, that is integrated circuits, at Texas Instruments in the year 1958, and advancements in the operating systems have been started in the year 1960s, and next microprocessor have been invented by the Intel in the year 1970, and IBM is the company which has provided the personal computers in the year 1981. After that, they have developed using that resources by using LSI technology, that is large scale integrated circuits, in the year 1970s. After that, after LSI, the next era was using VLSI. After LSI, the technology have been improved. After that, VLSI have been started using. So VLSI stands for very large scale integrated circuits for using the digital computers. And in the year 1980, after VLSI, the next advancement is using ULSI technology, that is ultra large scale integrated circuits. And these are the ICs that are using currently. And one more thing is mass storage and display systems. So here display systems means it is regarding the size of the screen, quality, resolution, and here storage means the size of the memory, because in order to make any tasks on digital image processing, we need to execute some sort of sophisticated algorithms, efficient algorithms, and large size of programs need to be executed and more amount of data need to be stored. So which is making the mass storage. So these are some of the advancements that are being made in the digital computer, one after another. And so the first computers, after they are invented, while making this image processing tasks, it has been started using in the year 1960s. And using that, this is the first picture that is being captured. So this is the image of the moon that is captured by US spacecraft Ranger 7 in July 31, 1964 at 9:09 a.m. So if we observe this image, so we can see here a small dots that is being done on this image. So we can see on this image there are small dots that are done. Using this dots only, this image have been enhanced and the resolution were improved. So the enhancement of the image and the image restoration have been done by using these dots which are present on the images. So we can see this is the first picture of the moon which is captured by US spacecraft Ranger 7 in the year 1964 around 9:09 a.m. So digital image processing have used in wide variety of applications. So in late 60s and early 70s, image processing applications were used in medical imaging, remote earth resource and astronomy. In all these applications, they used to use image processing. And coming to from 60s to present, this image processing techniques have been used for contrast enhancement and image enhancement and restoration. So this is how the origin of digital image processing have been taken from low level to high level. Now, so before speaking about the applications of digital image processing, we have to speak about this electromagnetic spectrum. So here, the electromagnetic spectrum will have different bands. So starting from the radio waves and it will be up to gamma rays. And here this radio waves is the low level and this gamma rays represents high level. So it is ranging from 10 power minus 9, minus 8, minus 7. So it has started from 10 power minus 9 and it is being increasing, and the maximum it has the wavelength range up to 10 power 6. So this is the electromagnetic spectrum. So electromagnetic waves means it is propagating the sinusoidal waves of varying wavelength. Or we can also represent electromagnetic waves as a stream of massless particles, each traveling in a wave-like pattern. So it will be traveling in a wave-like pattern and moving at the speed of light. So here we have taken one word which is called massless. So massless particle contain a certain amount of energy. So this energy we can also call it as bundle. So here we can see different bands in the electromagnetic spectrum. Each one can also be called as a photon. And here now we will see each application. That means here if we come to the radio waves, in which application this particular radio wave imaging will be used. So if we consider this microwaves, in which application this microwave imaging will be used. Now, coming to the detailed discussion of this digital image processing applications. So after being done many advancements, whereas in the digital computers, if you see, the performance of the digital computers are being increased, the cost of the digital computers have been reduced, so speed of operation will be high, so there is internet facility. So due to all these, there is a lot of scope to make many image processing tasks, which leads to these many applications. So based on the electromagnetic spectrum, we have seen it is ranging from radio waves to gamma rays. So in between you can see, after radio waves, microwaves, infrared, visible, ultraviolet and X-rays. So here this visible band is the wavelength where the human eye can be visible. The colors can be visible starting from red to violet. So based on that electromagnetic spectrum, here are some of the applications. So different applications here: gamma ray imaging, X-ray imaging, imaging in ultraviolet band, imaging in visible and infrared bands, imaging in microwave band, and imaging in the radio band. So if you see here, there is gamma ray, X-ray, ultraviolet, visible band, infrared band, microwave band, radio band. So all these are different bands available in the electromagnetic spectrum. So based on that band wavelength, we will see to which application it is suitable. So the first application is here gamma ray imaging. So this gamma ray imaging application will be mainly used in the nuclear medicine and tronomical. If we discuss, it is broadly used in this nuclear medicine. So if you see how it is used in the nuclear medicine, means in the nuclear medicine, we are going to inject this nuclear medicine into the patient with a radioactive isotope, and it will be emitting the gamma rays as it decays. So here generally by using this technique, images will be generated. So such type of images will be generated. So these images are produced from the emissions collected by gamma ray detectors. So this is one of the example image that is being captured by using this gamma ray imaging. So if you see here, this is gamma ray imaging, and it is the image which is representing a bone scan. So in order to scan the bones in our body, generally this gamma ray imaging will be used to capture that particular images. And next application is X-ray imaging. So here this X-ray imaging, we all of us are very familiar about how to take X-ray in order to diagnose any problem. So here major uses, we are going to use this X-ray imaging in the medical diagnostics. So what is the process that is happening? Images are generated by using this X-ray tube. How it will be captured means, the patient will be placed between the X-ray source and the film sensitive to the X-ray energy. Then that particular image will be captured. As the intensity of that rays will go on increasing, it will be increased to a particular level, so that the image will be captured with a high quality. So this is an example image, this is the example image which is captured by using this X-ray imaging, and this is the image of chest X-ray. Next application is in ultraviolet band. So how this digital image processing, in which applications we can use if the range is in the ultraviolet band. So here are different areas where this ultraviolet band imaging concept can be used. One is lithography, industrial inspection, microscopy, lasers, biological imaging, and also astronomical observations. So among all these, majorly this ultraviolet band is widely used in the area microscopy. So for example, if you take fluorescence microscopy, okay, so it is the area where this ultraviolet imaging will be applied. So this is the fastest growing area of microscopy, and how this process will happen. It is one of the method for studying materials that can be made to fluorescence. For example, whether the material is a primary fluorescence or whether the material is whether the chemical have been added to the material, that is secondary fluorescence. This particular images can be captured by using this ultraviolet band imaging. So here is one of the example image that is being captured under this ultraviolet imaging concept. Okay, so this is the first image A, which is representing the normal cone, and this is the one which is representing the secondary fluorescence, that is the chemical is being added, which is called smut cone. Now, and the next application is imaging in visual and infrared bands. So this visual band is the band where the human eye can be visible. So major uses that where the applications can be used here is light microscopy, astronomy, remote sensing, industry, and law enforcement. So here we can see some of the example images that are being captured by using this visual and infrared bands. So here if we see the first image, it is the image that is it is the image of thumb print, which is being captured in the range of visual spectrum. And the second image, if you see, it is the image of paper currency, and this image is also being captured by using visual spectrum only. So these are the main applications where this visual and infrared bands are applied. In these areas, this particular range can be applied. So these are some of the applications of digital image processing, and this is how digital image processing have been started. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.